under the flaps, and this was part of the response page. So you can turn that off if you need to get it. I need to erase it and go on. And it turns out that there are some relationships. I'm also still on page 94 and the response side to this. And this is there are some relationships I want you to notice. So let me put up the special triangles. I'll put it up this way, just show you it doesn't matter which way. 60, 30. So this is 2, 1, square root of 3. And then our new one from today, 45, 45, which is a 1, 1, square root of 2. Commit those two to memory. They should be in there somewhere from your geometry days. Let's look at the relationships. Sine of 30 is what? Well, sine is opposite over hypotenuse, so I come to the 30, 1 over 2. What is cosine of 60? Well, I notice I come up here, 60, cosine is adjacent over hypotenuse. Also 1 over 2. So these are equal to 1 over 2, so they're equal to each other. So presto changeo, I write that. Let's look at, say, cosine of 30. That is adjacent over hypotenuse, and the square root of 3 over 2, and sine of 60. From 60, I go opposite over hypotenuse, also square root of 3 over 2. So they are equal to each other. How about that? Pretty interesting. Does it pop up again? Let's try tangent of, say, 30. So we're coming over here and we're doing opposite over adjacent. I will leave it in the unrationalized way for our discussion. And let's look at cotangent of 60. Cotangent is adjacent over opposite. So I come over here and I go adjacent over opposite, 1 over the square root of 3. Also indicating these are equal to each other. How about cotangent of 30? Cotangent of 30 is adjacent over opposite, square root of 3 over 1, or square root of 3. And let's compare that to tangent of 60. Tangent of 60 is opposite over adjacent, square root of 3. Surprise, surprise. And one more set. Let's look at secant of 30. That's hypotenuse over hypotenuse over adjacent, hypotenuse over adjacent, 2 over square root of 3. Compare that to cosecant of 60. So cosecant of 60 is hypotenuse over opposite, 2 over the square root of 3. So these are equal to each other. And without step by step, please believe that cosecant of 60 is the same as secant of 30. These relationships pop up no matter what angles are here and here. So if I was to change this to theta, so that's an unknown angle, but it isn't a right triangle. It turns out that theta is related to this angle in this way. This angle plus 90 equals this angle, this angle plus 90 plus this angle equals 180. So I'll call it angle. So theta plus angle plus 90 equals 180. Because all the angles in a triangle add up to 180. So what can we solve for that and rename it? A equals, move the 90 over and the theta over, and you get 90 minus theta. So this angle, if it's a right triangle, this is only true for that instance, 90 minus theta will be the name of that angle no matter what. So whatever this is 90 minus theta. So if this is 30, this is 90 minus 30, or 60. If this is 50, this is 90 minus 50, or 40. That relationship is always true. So I'm going to bleed that over here. So sine of theta is going to be the cosine of the other angle. I'll call it the other angle, but I'll write 90 minus theta. Cosine of theta is the same as sine of the other angle. And we saw that for just one instance, but it's true for every instance. Tangent of theta is the cotangent of the other angle. Cotangent of theta is the tangent of the other angle. And secant of theta is the cosecant of the other angle. And cosecant of theta is secant of the other angle. So there we have some remarkable relationships, and it brings up another point. They're coming in pairs here. Look at this first pair. We have sine. This relationship is between sine and cosine. Sine of an angle is cosine of the other angle, as well as cosine of an angle is sine of the other angle. So this relationship, they're cooperating. So sine cooperates with this and becomes cosine. That's why we call it sine and cosine. They cooperate in this way. Tangent cooperates with cotangent. They relate like this, and we call it tangent and cotangent. Secant relates with this one in this mysterious way, and we have secant and cosecant. And I always wondered why they were named that, and this is the relationship. I'm sure you were wondering as well. This is the relationship. Sine cooperates and becomes cosine, tangent, cotangent, secant, cosecant. All right, that ends our discussion on special triangles, and I'll see if there's anything else that needs to be put on that page. I think that's it. What we did the rest of the class was, let me check the time here. I'm going to shut this one down. Oops, it's still recording. I'm not sure if I shut it off. Let me try to shut it off again.